Here we have the 30th question of limit, but the question looks a little lengthier. Yeah, my dear friend, question is a little lengthier. By the way, let me read it. If f of x equals to modulus of x plus 1 when x is less than 0, f of x equals to 0 when x equals to 0, and f of x equals to modulus of x minus 1 when x is greater than 0, for what value of a does limit when x tends to 0 f of x exist? So what is the condition of a? What should be the value of a that this limit exists? It means the left hand limit, right hand limit get equal. So okay, let's try first when a equals to 0. All right, when a equals to 0, what is going to happen? Let's check up the limit, right, at a equals to 0. So our left hand limit 0 minus f of x, and now you should tell me which function you are going to choose when x is 0 minus. I know you're very smart. Yes, here our x is slightly smaller than 0. 0 minus, it means it's not exactly equals to 0, but a very little smaller than the 0. So here x is our less than 0, so definitely this we are going to pick up. And my dear friend, the modulus value of x has 3 value: minus x, x plus x, and 0. When x is less than 0, it means when x is a negative number. When x is greater than 0, it means when x is a positive number, and x equals to 0. So this time 0 minus, it means less than 0. All right, less than 0, it means it's negative number. So that time it is minus times the whatever we have. So plus 1 and limit x tends to 0 minus, as I told you, it will be the value of modulus value of x will be minus of x plus 1. And now let's plug the value of x, 0 minus, so it will be minus 0 plus 1, that's 1. Similarly, let's find out now right hand limit. All right, so our right hand limit will be limit x tends to 0 plus f of x. And now you tell me what will be the correct choose of the function f of x when our x is approaching to 0 plus. 0 plus means slightly more than 0, it means definitely it will be our function. Right, so it will be now limit x tends to 0 plus absolute value of x minus 1. And as I told you, that whenever the value of x is slightly bigger than 1, it means it is positive number, and when it is positive number, the modulus value is just that number. Right, so it's just going to be x minus 1. And now let's plug the value of x, so it's going to be 0 minus, and it's minus 1. Oh my god, the left hand limit is 1 and right hand limit is minus 1. It means left hand limit does not equals to right hand limit. It means limit does not exist. So what we can say that at a equals to 0, the limit is not going to exist. Now let's suppose when a is let's say greater than 0. All right, when a is greater than 0, what happens? Let's check it out. So let's find out the left hand limit first. For a greater than 0, limit x tends to a minus f of x, and again limit x tends to a minus. All right, now see here, a is itself greater than 0. So when x is greater than 0, x is greater than 0, we need to choose this function, that is absolute value of x minus 1, absolute value of x minus 1, and further limit x tends to a minus absolute value of x. When x is a positive number, it means here a is greater than 0, right? A is greater than 0, it means it's a positive number. So if a positive number is inside the modulus value, inside the absolute value, then the same number come outside. All right, so it will simply x minus 1, and now let's plug it, so it will be a minus 1. Similarly, let's find out the right hand limit. It means limit x tends to a plus and f of x, again limit x tends to a plus. Now what will be the best function, f of x? In the place of f of x, what we need to write here, a is greater than 0, keep in mind, and it's slightly even bigger than 0. All right, so again go here, x is almost equals to a. All right, and here it is greater than 0, definitely again it will be the answer. I mean it will be the best option. Root x minus 1 limit x tends to a plus, now see x is a positive number again here, because x is approaching to a is itself greater than 0, it means a positive number. So if it is positive number inside the absolute value, it means the same number will come outside, x minus 1, that is now we can plug the value of x, that is a minus 1. Wonderful, because left hand limit is also a minus 1 and right hand limit is also a minus 1. So what I can say that left hand limit equals to right hand limit. This gives us limit exist when a is greater than 0. So when a is a positive number, always limit exists. Now let's check when a is smaller than 0. When a is smaller than 0, it means when a is a negative number. So let's find out left hand limit, and that will be limit x tends to a minus f of x, and again limit x tends to a. Now see here, a is smaller than 0, it means it's a negative number. So what will be the appropriate, the correct choose of the function? X is approaching here a, alright, so this time x is smaller than 0, it means it's a negative number, so that time this will be our appropriate function. So it's absolute value of x plus 1, alright, again limit x tends to a minus, now see here a is itself a number that is smaller than 0, so definitely this is here, x is a negative number inside the absolute value. So whenever a negative number is inside the modulus value, absolute value, minus will multiply that number and then whatever it is. So let's plug the value, it's now minus a plus 1. Alright, again now let's find out the right hand limit. Right hand limit will be now again limit x tends to a plus f of x. See again x is going to approach a, alright, it means the value of x is almost very close to a, but it's a little bigger than a, right, little bigger than a, and a is a negative number, already I told you. So when a is a negative number, a is less than 0, we have to again choose the same function, alright, that is limit x tends to a plus absolute value of x plus 1, and the same thing it is again going to repeat, the same thing it is going to repeat, that's limit x tends to a plus absolute value of x, because again this x is a negative number, so it will be minus x plus 1. Let's plug the value, it's gonna be minus a plus 1. Wonderful, again we got the left hand limit and right hand limit equal. So again left hand limit is equals to right hand limit, that gives us limit exist when a is smaller than 0. Alright, so whenever a is smaller than 0 or a is greater than 0, limit exists, but if a is equals to 0, then that time limit does not exist. Alright, so the final conclusion, what we can say that limit x tends to 0 f of x exists when a is not equals to 0. When a is equals to 0, limit does not exist, and when it's bigger than 0 or smaller than 0, always and always the limit is existing.